distance. Go over a few of these problems here. Quadrants, you should remember that it goes by your degrees here. That's where we come up with our quadrant numbers. So we start at 0 degrees, work our way up to 90. So this is why this is quadrant 1, 90 to 180, quadrant 2, 180 to 270, quadrant 3, and 270 up to 360, quadrant 4. Okay, so just recalling that. Draw a mapping for the relation. Remember, relation is a set of points. Oftentimes it is here, but it could be other things as well. And so we have the x coordinates are the input and the y coordinates are the output right here. And so notice in the x we have 4, 6, and 3. 4, 6, and 3. Okay, for the y we have -1 and 2. Notice I've only written -1 and 2 because we do not do any repeats when we put our mapping like this. Okay, so all you're doing is putting arrows to it. So 4 goes to -1, 6 goes to -2, and 3 goes to -1. Okay, just like that. As it says here, no repeats are allowed to be written down. Okay, so that's why we have 2 arrows going to the -1 there. Okay. Which of the following equations are linear equations? Or linear, keyword is line. If it's linear, that means the exponents on the x and y are 1. Okay, so that's where I need to check. So if I look at A, that x is 1 and that y is 1. So that's linear. That's why you see A right here. If I look at B, that y is 1. Okay, so we have B. If I look at C here, this x is 2. It can't be. That's a quadratic. It's going to graph into a parabola. So C is not there. I look at D. That's fine because I can rewrite that. It's all about the exponents on the x and the y. Those are just fractions, 1/2 and 1/3. So the x and y both have 1 as their exponent. So that's D works. And E does not. So even though you see a 1 down here, the problem is you got to look at what it really means when it's in the numerator. In order to move something from the denominator up to the numerator, I have to do the inverse, which means put the negative on it. So it really says 5x to the -1 plus 3y to the -1 equals 8. So now when I look at my exponents here, notice they're -1 on both the x and the y. It only had to be on one of them to make it false. Okay, they both have to be 1s. So that's why E does not work. So your answer is just A, B, and D. Okay, let's go to the back side. Look at a couple examples here. Determine whether each relation is a function. So I wrote down the definition of function again. You should know that from Algebra 1 and Algebra 2, which you just got out of last year. Graphically, it must pass the vertical line test. So if I was to plot those, I would go ahead and see that whether it passed the vertical line test or not. I mean, when I draw a vertical line through any of the points, it can only cross 1 time. That's the key that you need to remember. Okay, so that's graphically. If you want to talk about it verbally or just looking at it without looking at it graphically, for every x, also called the input, okay, there's only one y. Or output. Okay, you should have this memorized. Okay, you're going to go on and use this in college functions all the time. Okay, so for every x, there's only one y. Notice it does not say for every y, there's only one x. There can be repeat x's, but it can be no, this means there's no repeat y's. Okay, so right here, this means no repeat y's. Okay, So if I look here at my y's here, are there any repeats there? No, there's not. Okay, so I know therefore that b is a function. Okay, how about here? C. So that's yes. Then write the letter for each function in the answer blank. Determine whether each relation is a function. Then write a letter for each function in the answer blank. So B is. How about here though? Repeat y's. So C is not. D. Now here x equals 11/3. What kind of equation is that? You need to know from Algebra 1 and Algebra 2 and pre-algebra, this is a vertical line. And so if I draw any vertical line, how many times is a vertical line going to go through that line? Every single point. So that fails as well. And then here I just get y equals 3, and that's a horizontal line. And so if I draw any vertical line through a horizontal line, it's only going to hit one time. So all horizontal lines are functions. And then on A, graphically, okay, I'm just drawing vertical lines, in this case segments, they're only going to hit one time. So A also works. All right. Find the f of 4. If you forgot what that means, you did that in Algebra 1 and Algebra 2. It just means plug 4 into whatever this variable is here. In this case, it's x. So plug it into here as well for every x in the equation. Okay. Function notation. That's what that's called right here. If you forgot that, function notation, g of x or the fx. The g and the f are called the name of the function, and the x is the independent variable. So speaking of that, this would be independence as well. Okay. And output, another word for that is dependent. So these are all math words that represent x and y coordinates. Okay. Input, output, independent versus dependent. Remember, we graph the independent coordinates on the x-axis dependent on the y-axis, just like the x and y themselves. Okay. Let's see, anything down here? Okay. Find the median, lower quartile, upper quartile, and inner quartile range of the data below. And determine if there's any outliers. So we have all these vocab. You did this in Algebra 1 and perhaps in Algebra 2 as well. You did in Algebra 1 for sure. Okay. So first thing, remember, you have to do is put them in numerical order from smallest to greatest, which they already are for us. They already did that for us. So that was nice. Okay, then I count. Remember, I get the median is the middle number. So how many numbers do I have here? 1, 2, 3, 4, 5, 6, 7, 8. Okay, that I can get rid of that. Okay, so there's 8. So I got to pick the two middle numbers. Here's my two middle numbers, and the median is the midpoint between those two middle numbers. You see I have 3 above and 3 below. These are my two middles because I have an even number. Anytime you have an even number, you're going to have two middles. There's an odd number, there's going to be one exact middle. So what is the midpoint? How far is from 27 to 19? 8. What's half 8? 4. So I can either add 4 to 19 or subtract 4 from 27. I get 23. That's where the 23 is. So that's the median. Now, how many numbers do I have to the left of 23? Okay, so now I have 1, 2, 3, 4. So I got to take these two middle numbers because I got an even number. What's the midpoint of 10 and 16? 13. So that's the lower quartile. And of course, I also have 4 in the here as well. Remember 23 is right here. So I have 4 in the top. So I take the two middle ones there. The midpoint of 31 and 35 is 33. So that's called the upper quartile. U, Q, That's my medium, and that's my LQ, lower quartile. All right, interquartile range means interquartile range. This word right here, or these two words right here, is the upper quartile minus the lower quartile. You just subtract the two. So 33 minus 13, interquartile range right here. 33 minus 13 is 20. Okay, so now we've found that one. We found the median already, found the lower quartile 13, the upper quartile 33, the interquartile range. Remember, range ought to automatically tell you you're subtracting high. It's usually high minus low, but you can also have interquartile. So it's telling you which ones to pick and subtract. Range is always subtraction. Okay, so we did the interquartile range. That gives me 20 and any outliers. Now the definition of an outlier right here. It's the interquartile range. Remember, we just found that out right there, 20 times 1.5, which gives me 30. So if I go 30 beyond the upper quartile, or the upper quartile is 33, so 33 plus 30 is 63. Do I have a number beyond 63? Yes, I do, 64. So there's an outlier right there. Or if I take this lower quartile and subtract 30 from it, 13 minus 30 is negative 17. Do I have a number below negative 17? No, I don't. So I don't have any outlier on the lower side, but I do have an outlier on the upper side. Okay, so those are things you need to memorize that you've already learned from Algebra 1, and you might have done it also in Algebra 2. Okay, so you got to get those down on how to find those. And that will cover it for this lesson, 12 minutes.